Welcome to this tutorial I'm going to be doing with you today about the differences between the types of muscle you have in your body. And this will just be a refresher of some of the major differences to help you separate each type in your mind. If you need a more exhaustive list, look for my videos on the individual cell types themselves. So let's start with the obvious part. They each have different names. We have skeletal, cardiac, and smooth, and they're all structurally going to look quite different as well. So what they look like. Here we can see I've just quickly sketched up what each type is going to look like, and we can quickly differentiate each one based on a few things that we can see straight away. The first thing we can see about the skeletal and cardiac muscle is that they have these strange lines running all the way through them, and we call those striations. So cardiac and skeletal muscle is striated by all of these lines, and that's going to be caused by the banding pattern of the thick and thin filaments that you have inside your sarcomere. And you can see that your smooth muscle doesn't have this banding pattern. But don't get me wrong, your smooth muscle is still going to have myosin and actin in it working in a sliding filament method. They're just not going to be arranged into sarcomeres like in your skeletal and cardiac muscle. So what's the next thing we can see that differentiates these cells? Well, your skeletal muscle is going to be multinucleate, so we can see these many nuclei all throughout the cell. And with your cardiac cells, they're usually classified as uni or binucleate, meaning they usually only have one or two. They're not big enough to need more than that. But with your smooth muscle, it's always going to be uninucleate. So uninucleate, it only has one, unless you have some kind of intracellular mutation. Okay, so we've differentiated them based on whether they are striated or not, and also how many nuclei you would expect to find. But we haven't yet separated them based on how the whole cell itself appears. Now for your skeletal muscle, the cells are going to be long and rod-like, remembering that a single cell could be up to 30 centimeters long, which is quite ridiculous when you think about it. And with your cardiac muscle, they're going to be small and branched, so it's going to come into direct contact with several other cells at their branching points. So we can see we have these branches here, and we'll have another cardiac myocyte branching off here. And our last type, the smooth muscle, is going to be a fusiform shape. Fusiform meaning it's wide at the middle and is then going to taper off toward the ends. So it's wide and then it's going to taper. So we've covered all of our basic differences now in how the cells look, but where are we going to find them? Now I've just got these few sketches up here to show you. We're going to find skeletal muscle attached to bone, so skeletal as in the skeleton. That's going to be acting on bone as levers. Cardiac muscle we're going to find within our heart, and smooth muscle we can find within our blood vessels. We're pretty much going to find smooth muscle on the walls of all of our hollow organs, so stomach, intestines, our esophagus, and all of our blood vessels as well. Well, I shouldn't actually say all of our blood vessels, but we do have smooth muscle in quite a lot of them. Now, how do we regulate these cells? Are they going to be voluntary or involuntary? Do we control it or does our body control it? Skeletal muscle, we know we control that, right? So it's voluntary. We don't just go to the gym in the afternoon or the morning and then mysteriously our arm starts curling itself. We have to tell it to. So skeletal muscle is voluntary. Cardiac muscle, on the other hand, is not voluntary. So it's an involuntary muscle. We don't tell our heart how fast to beat. It decides how fast it's going to beat based on how much stress you're going to put on it, and that will be achieved by your pacemaker cells that are within your heart. And lastly, our smooth muscle, also involuntary. We don't tell our body how quickly to digest food or how quickly to get rid of waste or pump blood around our body. Our body does that itself. But I'll point out as well that your smooth muscle and cardiac muscle can also respond to stretch. Now, if you've got a full stomach, or if you've got lots of blood pumping into your heart because you're exercising a lot, your body can detect that via how much that organ is being stretched, and it will regulate the activity accordingly. So if we're regulating activity, one of the things we'll be regulating is the speed of contraction. And with your skeletal muscle, because it's voluntary, that's going to vary depending on what you want to do with it. Whether you're sprinting or whether you're just doing a light jog, your muscle contraction will vary. So we can see here that this contraction time is varying. So we've got fast contractions and the slow contractions that we started with. Now with our cardiac muscle, it's going to be most of the time quite slow and also rhythmic. Rhythmic meaning it's happening over and over and over, and it's not going to get tired. Your heart doesn't need an hour break every now and then. It's going to go on and on and on rhythmically and steadily. And lastly, our smooth muscle is very slow. So if we eat a large meal, we're not going to digest it and then need to go to the bathroom within 5 minutes unless we've eaten something that's very, very bad for you. So it's going to be slow and it's just going to go about its job nice and leisurely. And the last thing we're going to talk about in this tutorial is where each of your different muscle types get their calcium, because we know we need calcium to initiate contraction, right? So where does each one actually get it from? Well, with your skeletal muscle, it's mostly going to be coming from the sarcoplasmic reticulum. And if we remembered, our sarcoplasmic reticulum was the network of tubules that we have wrapped around our individual myofibrils. And if we pretend this is a individual myofibril for a moment here rather than a whole muscle cell, it's going to be wrapping around it kind of like this and supplying calcium to that myofibril when it's ready to contract. So we've got the SR here, your sarcoplasmic reticulum. But with our heart, we still have a sarcoplasmic reticulum, nowhere near as dense as what we have on our skeletal muscle though. Also, we're going to be getting our calcium from extracellular fluid. And I'll show that up on here. So if we have the cell and we've got calcium floating around outside the cell, just in the ECF, we're going to have receptors or channels on your cell that the calcium can enter into. So it can enter through the ECF like this. And our smooth muscle is not too different. We're still going to have a small amount of sarcoplasmic reticulum like with our cardiac muscle, but we're also going to be getting it from the ECF. So I'll just point out as well that our sarcoplasmic reticulum on our cardiac muscle and our smooth muscle is much less dense than our skeletal muscle because we have that extracellular fluid source as well. And with that, we've covered a few of the major differences between our cardiac, skeletal, and smooth muscle. Like I said at the beginning, if you need more in-depth information, then have a look at my videos on the individual cell types themselves. Once again, I hope this video has been helpful to you. Thanks for watching, and I'll see you all again soon.